Sup guys, welcome to today's show. So we are almost done with our file system implementation. What is left is reading and writing data and opening directories and files. So hopefully we can do all of this in this episode, ending this series. And this is a sub-series of the OSdev series. So we will still keep doing the operating system development, of course. All right, so where do we start? I think I want to start with the open directory. So basically, I want this function to let us provide a file path. So like C:, Windows System 32 or something. And it should return a structure with the file contents of that directory. So all the file names, their sizes. I would like to have some kind of a timestamp when the files were created, but I can't really fit that inside of the 32-byte inode structure, unfortunately. But maybe we can figure something out later on regarding that. But however, the important thing is being able to list the contents of a directory, so that's where we'll start. And in order to do that properly, we need to parse this string containing the path name. And that might be a little bit tricky, perhaps. Right. So let's see. If we have a string like C:, Windows System 32, first of all, we need to get the drive number from this first character. And that shouldn't really be a problem, right? By the way, I want to use forward slashes and not backward slashes. Then we want to grab this string, which is in the middle of those two slashes. And we want to search to the root directory for an inode, which corresponds to this file name. If we find it, we want to open up this directory, and we want to continue this iterative process on a hop-by-hop basis recursively. Yes. So we need a function which let's see. Which opens a directory inside of an inode and return that inode. Right. So if we have that, the rest should be rather simple, I guess. I hope. We'll see. So let's start in that end. We want to define a private function which will return some new no, it will return inode, so a pointer to an inode. And what should we call this? Let's call this read directory. So it will take a file system it will take a pointer to an inode, which is the directory that we are searching. And then it's going to take a file name specifying the directory that we want to look for. Yeah, I think that's it. So let's copy this thing. So we'll call this fs, we will call this haystack. Because we are searching the haystack for the needle, right? And the file name is the needle. Alright, let me just reconnect my electric cable so my laptop will not die on me. Okay, so let's see. First we'll check that we have a file system. And a needle. Otherwise, well, let's set the error, what did I call it? Error number to error no error. So if this happens, we can return an error of error argument. We want to create an inode pointer. Maybe we should call this P. We need to have some function which compares the two file name structures. Right. And I also want to have some function which is called when we save an inode to disk, and it goes through the file name and turns all the characters to lowercase, because we don't want to be case sensitive. So let's create those two functions inside of the OmniSTD, I think. So let's open up the .h file as well. So two functions. We need to have a memCompare basically. So internal bool memory compare. And it's going to take a pointer to the source, the destination, if one could call it that, and the source, maximum size, and a boolean if this is going to be a string compare or a memory compare. So we'll do like we did with the string copy. We will define a macro, which we will just call, string compare. So we will have destination source number, and we will call memory compare with the destination, the source, the number, and since this is a string compare, we want to set the bool to true. So we'll copy this and we will create something which we just call compare. And it will do the exact same thing, but it'll set the boolean to false. So that's one function. The other one, right. So the other one is the, what should we call that? To lowercase. So let's say it's an internal void to lowercase, and it's gonna take a file name, which is the destination, that's all, I guess. So let's start with that one because it's more simple. Alright, so internal void to lowercase, take a file name, and we need an int 8 p, and we need an int 16n. We'll do a for loop where we set p is equal to the name. We will set n equal to n equal to 8. We're going to loop as long as we have an n. At each iteration, we're going to increase p and we're going to decrease n. And we will set the current character equal to, and we need some lowercase function. So let's say low of P, right? That should be it. Maybe we can just do this, by the way. If we set P equal to the name, and we cast this as an int 8, then we can set this to 11, and we go through every single byte. That's a better way, I think. And let's also check that if P is not 0, then we do this. And then we can just return nothing, right? Good. So we need to create our own lowercase function. Shouldn't be too hard, right? So this will be an internal int 8 low, and it takes an int 8. So internal int 8 low, int 8c. So let's see what we have. If we print a single A, for instance, and we hex dump it, I think it's for 41, yes. And the maximum bound is Z, which is 5A. So if we're inside that range, we will do one thing. So if C is more than 40, and C is less than 5B. So this means that we are inside the range of capital characters. Let's create one more int 8. So let's say this is X. And what is the range of the small characters? They go from A to C, so from 61 to 7A. So if we take the character minus Let's see. If we take the character we have and we minus 0x41, then we should have a 0 for the A. Let's do that to begin with. So x is equal to C minus 41. So the value that we have, we want to add 61 to, right? So x plus equal 61. And then we should be at the same position in the lower character range as we were in the higher character range. Which means we can safely return x. And if we are not inside of this range, we will just return the input, like so. Okay, cool. So let's try this out. Let's go to this mount thing again. fs mount. And let's create the character C. We'll set C equal to a capital J. And then we print character like so. The low of, we need to do a character cast of low of C. And then we try the same thing again, but this time we have a small x for a small x, so that should return the same. So if this works, the C should first be equal to a small j and then a small x. Right. Okay. It complains that it doesn't know what a file name is, and that is true. Maybe we should make this a little bit more general. Let's just say we have an int 8. So we don't need to cast this, but we can still treat it exactly the same. So let's go into here and change this to an int 8. And then inside of the fs.h we can create a macro which we call, what did we call the other one? to lowercase. So let's say we call this file name to low. And it takes an X and we return to lowercase of an int 8 casted X, like so. That's a good enough solution, I think. This should be printf. This should be printf. And what was the other one? Unused variable p. Well, we're not done with this one yet. But for now, let's just return 0. Alright, let's try this. Command.com. C is equal to J. That worked perfect, but it did not work with the other one. So good that we tried that out. fs mount. We set C equal to X. And we do this. If C is more than 40, or, this should be an AND. This is why we do these kinds of tests. Alright, works perfect. Perfect. Okie dokes, where were we? Right, the read directory. We are going to need a pointer. Okay, so this read directory, we should begin with the haystack directory. So we need to open that up. We'll set p equal to find inode, and we have an fs and we have a haystack. If we don't have a p, we are going to return an error of what exactly? Error inode. Inode. And if we have a p, but the p valid type is not equal to a directory, so type directory, In that case, we too want to return an error. But first, we want to destroy the P. And then we return an error of, what are we going to call this? So we're trying to open a file as a directory. Yeah. Let's call this bad directory. So we will add this. And let's do like we did before. We create a comment section where we put all of our new error messages. So error bad directory. Otherwise, we have successfully opened the directory. So inside it, and this is a regular inode, so we have some indirect pointers and we have some direct pointers. So first we want to search through our direct pointers. Yeah. Pointer per inode. So let's create an n as well. So for n equal to 0, as long as n is less than pointer per inode, n++. Then we'll set our index equal to p direct of n. And if idx is 0, we'll continue. So basically we'll just keep on searching. However, if it's non-zero, we have found something. So this is another inode. So let's also have a second pointer. So we'll set p2 equal to find inode fs, and now we give the index instead. And if this p2 comes back as 0, we will just continue to the next one. But if we get something, we want to check, is this a directory or a file? But that doesn't really matter actually, because when we are reading a directory, it can be a file that we are looking for. It doesn't have to be a directory. So never mind that. Let's check the file name. So we'll do a comparison. And what did we call this function? Well, file name to low. But that we will do while saving. We can safely assume that all inodes are saved with lowercase. But we need to turn our search string into lowercase though. And that's our needle. So file name to low, and we give it the needle. So now we know it's lowercase. Now we can do the actual comparison. And we will not do the string compare because that is just let's see, because that will fail if we run into a file name with maximum size. So let's do a memory compare instead. So if compare of we will compare the int 8 of the needle with the int 8 of p2 name with a maximum of 11 characters. So if that is positive, that means we have found what we are looking for. And in that case, we want to return the index. So we will free p, we will free, no, not free. We will destroy p, we will destroy p2, and we will return idx. And if it doesn't match, we will just continue. Simple enough. Okay, so that was the direct pointers. But if we don't find it inside of there, we want to search the indirect pointers as well. So at this point, if we don't have any indirect pointers, we can return an error. So if p, by the way, before we do that, we want to free p2. So we don't leak any memory. Okay, where were we? If p indirect is 0, what do we want to do? P2 is already destroyed, but we need to also destroy these destroy the P at this point, and we want to return the error of file not found. So file not found. It's very long, file not found. Maybe just r not found, like this. Okay, so if we have an indirect pointer, that is a pointer to a block. So in that case, we want to read that block. So we need to create an fs block, bl, and I also want to have a pointer for the block number. So we will set the block number equal to p indirect. And we should probably need to have a function which returns that thing. Maybe later. Let's zero out our block first. We need to calculate the size, by the way. No, we know the size. So BL, or the address to BL, and the size is block size. So now we want to read in this block. So d read. Let's grab the return value, by the way. So bool ret. So ret is equal to d read, and we need to have a disk. So this is the fs. Do we have an fs, by the way? Yes. So this is the fs dd. We need to have an address, and this is the address to BL data. And then we need to know the block number, which we do. So block number. And if this returns false, in this case we want to destroy the P, and we want to return an error, but we don't really need to return an IO error in this case, I think. Let's just return error not found. Otherwise we have a block full of pointers, which we need to iterate through. So basically we do need to do this loop all over again. But a little bit differently. So n is still 0. This will not be pointers per inode, but this will be pointers per block. And n++. The index is equal to p. No, it's equal to the block dot pointers at the index n. That's it. And then we can do the same thing as we did before. Go through all of these. And if we at this point still haven't found anything, we can free our P. We can return the error of error not found. And that's it. Alright, so return ID X, read directory. Let's add these two errors so we don't forget it. So we go into the, this should be inside of the os.h. So we paste them here. Like so. And that's our read directory function. Alright, so let's do the valid file name next. And we need to define some string of characters containing all the different characters which are which we can put inside of a file name basically. So let's do that. We will define let's say valid file cars. So all the lowercase letters, numbers should be okay as well. What else? Probably not dots, right? Or will that cause any problems? Yes, we need to differentiate between those, so let's not use that. An underscore, I don't know about that. But people seem to like underscore, so why not? And regular dashes as well. Let's see, I'm looking through my keyboard now for additional characters. but I think this should be it. And do we have any other consideration when it comes to directories? No, that should be the same, only we will not care about the extension. So we can just name these valid characters. Let's make this an int 8 string. Okay. So now it should be rather simple to write these functions. Let's create a private bool for one character. So it will check if this single character is okay to have in a file name. So let's call it valid char. And it just takes one single int 8. So let's start with that one. Valid char. So private, how did I define it? Private bool valid char. Private bool valid char, and it takes an int 8c. We have an int 8p. And a bool ret, and we set ret equal to true. And we do a for loop, so we set p equal to the valid char's constant. And as long as we have a p, we increase p by 1. And at each character of that string, we want to check if our input character let's see if it's not if c is not equal to that character, let me think. Well, if our character is found inside of that string, we are okay. So if the character is equal to the one that we're checking, let's set this to false by default. If it's equal to our character, then we can return true. If it's not equal to it, we keep on searching. And if we've come to the end of this loop and we haven't found the character, that means we can return false. Maybe we can do like something like this. So if it's equal, we set ret equal to true and we break. And then we return ret. And now we can create the other function, which is called valid fname. It takes a file name and a type. So private bool valid fname. It takes a file name, and it takes a type, file type. Let's create an int 16n and a max. If we don't have a file name, we will return an error of argument error. We'll set max equal to if file type is equal to file to type file. In that case, we will search 11 characters. Otherwise, we will search 8. And if file type is not equal to type file, or let's just do this. If file name or file type, then we return an error. Let's also check. So if file type is equal to directory, extension, or the first character of that extension, is not 0. So basically, if we have a directory and we have an extension, this is also an error. So we return an error of error file name. Okay, so now I think we'll have all that we need for our loop. Let's also create a boolean, by the way. Do a for loop where we set the return equal to false. We will well, we need a pointer, right? Int 8p, and we will set p equal to the int 8 of the file name. We're going to loop as long as we have, maybe we can remove this max. We can remove this max, and instead of setting the max, we set n. So then we can loop as long as we have an n, and at each position we minus the n. We increase the p. So if let's see, for each character inside of that file name, we want to check that it's valid. So let's say we default to true. But if we find something that is not valid, so valid char of p, if this is false, then we can set our return to false, and we break. And after this loop, we can return ret. I think this is right. So, alright, let's try this out. We can do it like we have done previously by going to our fs mount, and we need to create a file name. Can remove all of this. zero out our file name first. Then we copy into our name. We copy our string out to exec. 8 characters. And to the extension, we copy bot, which is 3. And now I want to check, is this a valid file name or not? So if valid fname of name, and this is a file, if so we print true, otherwise we print false. And that's it. Let's see if autoexecbot is a file name that is allowed. After we fix the errors. 3, 4, 6. We need to cast this. Cannot convert to a pointer type. Needle and name 560. Needle is a file name. P2 name. P2 name should be an address like so. Same down here. Valid char undeclared 609. Valid chars. Redefinition of valid fname 618. Right, I created some empty function, didn't I? Valid fname. Right, so this we can remove. expected expression 618, if file name or file type. And let's remove those unused variables where we're at it. And now I believe it will compile. Almost. Uh, 6:15. This should be name. Now it should compile. There we go. Some warnings, but don't care about that right now. So command, and OSdev is okay, so this should return true. Valid equals true, that's good. Let's try something which is not valid. So fs mount, let's say we call it auto doc dot a bot. This should definitely not be valid. And it's not. Very nice. Let's also check the one that we have had, autoexec.bot, but we will try to create a directory with that name. So type directory, and that should not be valid either. And it's not. However, if we remove the extension, it should be valid. And it is. Works perfectly. Perfectly. Okay, so what do we call this function we just wrote? Read directory. I will add this here. We cannot really test this yet. We need to write at least one of the other functions first, I think. Alright. So I will put an X in front of this, and we will be right back after this. Alright, you guys, welcome back. So we are closing in on the end of this sub-project of the OSdev series. But we have some quite complicated functions left to write. And we're going to start with the open directory function. But before we can create that, we need to create some helper functions, and primarily we need to deal with parsing a path. So something like C:\DDoS system 16 driver.sys, something like this. So what I want to do to make this a little bit easier, I want to create some constructor function, something like make file path, or maybe just path. And it's going to take in a string. So it's going to take in a string, and it's going to return this path structure. And it's going to contain something like I want to have the drive number at the top. So in this case it should be 1 for the C:: drive. I want to have something called target, which is the actual file name or directory name, the thing to the rightmost string. So right of the last slash. And then I need to have some kind of array of strings where the first entry in this case will be the DDoS directory, and the second will be the system 16. So the target, this part, can either be a file name or a directory. So we can make this a file name structure. And these will be strings, since they can be both. I think that is the best way to deal with this. Because one more thing, we need to have some kind of size variable. So in this case, we have 2 directories. So the size will be 2. So that's the size of the array. So we know how many we're gonna go through. If we have something that parses this string into this, then we should pretty easily be able to write all the rest of the functions. Okay. So let's start in that end, and this will be called make path. And by the way, we created a out-commented version of this fstat, so this is also going to take a path. Alright, so let's create a private function which is going to return one of these path structures. Make path. And the only thing it's going to take is a string, so int8 star. We do also need to create this structure. So let's see. We should make this private, I guess. So it's going to be a struct as path, and it's going to be packed. So let's see what we need inside of here. First of all, we should probably, let's see, why not put the file system here as well? It will make stuff a little bit easier, I think. So we'll have the file system. We will have the drive number, which is an int16 drive. No, it's an int8 drive. And we need the size, which can also be an int8, even smaller actually, because we are only going to allow 16 levels. Let's define that, by the way. So let's call this directory depth, and it'll be 16. So this size variable will be somewhere between 0 and 15. So if we go and look how that looks in binary, 1, 2, 3, 4, 1, 2, 3, 4. So this is 1, 2, 4, 8, 16. So we only need 4 bits for that. And now I'm at the wrong thing. The size only need to be 4 bits. Then we need to have a file name. Let's call this name. And then we need this array. So it'll be an array of strings. Maybe we could make it null terminated instead. Then we can remove this size thing. So this will be int 8. What are we going to call this? So it's basically the directory path. Let's call it dir path. And this is going to be a 0-sized array. So when we allocate for this, we will take into account how many entries we need. I guess that's a good way to do it. But in that case, we need to know the actual number of entries we're gonna have. Maybe we can use this max depth instead. And then we do a type def struct s path, and we call this path. All right, let's see if we can create such a function. So it's going to be a private path, make path. It's going to take an int 8 string. And let's have a comment with some path. So we can take the same example. Deados system 16 driver.sys. So we need a file system fs. What else do we need? We need one of these structures, right? So let's do it. I don't think we need to make it a pointer. Let's make it a static path. Path, what should we call it? Well, this is going to be the return value, so let's just call it ret. But we didn't want it to be a pointer. Let's call it path prime then. And we do need to have a pointer as well though. So let's create a path pointer. Something like that. And a drive number. So let's have an int 8c and we'll have a drive as well. So let's first check that we have a let's do this. Let's check that the string is not null. So if it is null, or if the first character of the string is null, then we need to return an error of some kind. So let's start by resetting the error. So r number is r no r. We'll return the error of what exactly? R, do we have a path? But this is more like an argument error, because we're not providing the right thing. Okay, otherwise we want to start by grabbing at the drive character. So we'll set C to the lowercase version of the first character in the string. But that depends actually, because the path could also be something like this, without this first part. Right. So what do we do in that case? Maybe we need to take the file system as an argument after all. Let's remove this and add the file system fs. But we don't know what the file system is. Because if we are specifying the C:, thing, then we don't know what file system it is when this function starts. This became a little bit tricky. Maybe we can optionally provide a file system. and it's up to the calling function to sort that out. So let's add file system star. So let's check the second thing in the path in the string. So index 1, and if this is equal to a colon, then we can read the drive number. So in that case we set C equal to the lowercase of the first thing in the string. And let's see. The character B, which is not allowed, has 62 in hex, which means that we should be able to set the drive equal to C minus 0x 62. No, 62. Because the C is 63. So in that case we have 63 minus 62, which is 1, and 1 is the correct drive number. So this is a good way to do this. But we do need to check that it's in range though. So if C is less than it's less than A, or rather the int 8 of A, or C is more than the int 8 of C, so then we are not in the range, and we need to return an error. So we'll return the error of R directory. Well, we need a bad drive number. Do we have a disk maybe? R disk? No. Alright. Error drive. And as we did before, let's create a comment here where we list all the errors we want to add. So error drive. Alright, otherwise we can set the drive equal to this. So that is if we have a drive specified. If we don't, we want to check, do we have a file system? And if we don't have file system specified as a parameter, then we can't continue. So what are we going to call that? Error path, perhaps. Or actually, this is to an argument error. So if we come down here, we should have a drive. At least we should be able to do an else here and set drive equal to the fsdd drive, like so. Okay, so that's the drive. That's the easy part. Now we need to parse everything else here. By the way, if we have this, we should increase the string. So string plus equals 2, which means we were here and now we're here. So drive or no drive, at this point we should be left with this. Okay. So we need some kind of function which will search for a specific character inside of a string. And we need to be able to search both forward and backwards. So this sounds like something we should put inside of the OmniSTD, right? So this will be an internal function. Let's call it find char. And it's going to take a string. It's going to take a character. And it's going to return the position where that string is. So int a star. And we also need a direction. So let's say a bool. Then we can use this to create two macros. Let's say find char left. And this will only take the string and the character. And it's going to return find char of the string, the character. Let's not do this. String, the character, and let's say this last thing is named left. So is it going to search for from the left or not? And in this case, left is true. And then we can have a find char right where this is false. Right? So this is an internal function, int8 find char. It's going to take an int8, let's call this the haystack, and an int8 needle, excuse me, and a boolean from left. So we need an int8 pointer. We need a boolean for the return value. No, we need a position for the return value. So basically just p. We do, however, need the size of this string. Alright, so let's set the size, or maybe we could call this the index instead. So the index will be equal to the string length of the haystack minus 1. So before we do this, let's check that we have a haystack. If we don't, we can return an error. Okay, so now we have the index of the last character. So we'll do a for loop. Let's see. We'll do a for loop where we set p equal to so if we are searching from the left, it should be equal to the haystack, and otherwise it should be equal to the haystack plus the index. We're gonna loop as long as we have a p but if we are searching from the right, we need to know when to stop, because we will probably not have a 0 byte before the start of the string. So we need to also decrease the index. So as long as we have a p and an index, and at each position so if we're searching from the left, we want to decrease p, no, increase. And if we're searching from the right, we want to decrease it. And in both cases we can decrease the index. That's quite the for loop, don't you think? And at each position, if p is equal to the needle, then we set our well, I guess the easiest thing would just be to break at that point. So either we stop the loop because we have gone through the entire string without finding anything, or we break out because we did find a needle. So we can return if p is equal to the needle, then we return p, and otherwise we return 0. I think this is going to work. Okay, let's go back here. So first we want to find this target, the file name, or the directory name. So we need to search for the slash from the right. Let's create an int 8p. So p is going to be equal to find char from right, and it takes the string, which is str, and it takes a character, which is the slash. And if we don't find any slash, what does that mean? That means we have a local file name, so not a fully qualified path. Should we support this? Or should it be up to the calling function to translate that stuff? I think we can, yes, we'll let the calling function decide. So if we don't have a p, we'll just return an error of error path. Or what do we call it? Path. Error. Well, let's see. What is it? It's a bad path name. We need a specific error for that, I think. So let's add it to this list. Okay, so otherwise p is currently pointing towards this slash. So we can increase p, and now it's pointing towards the first character of the file name. and that is a null terminated file name. So we can just do a string copy. So we string copy, no, string copy like this. So the destination is going to be the path structure dot name Well, we need to turn this into a file name structure, but I think we had some function for that, right? What did we call that? File to string. But that's the other way around. Don't we have any string to file? How did we do it in the other cases? Did we just manually copy, or? Let's see. If we search this whole document for the string copy followed by anything and then followed by ext, here we go. File to string. No, we just have this. Well, it should be rather simple to write an opposite function, right? So internal int no file name string to file, and it takes an int 8 string. So let's see if we, no, that's the wrong place. If we don't have a string, we can return an error. Bad. Argument. Which means we need to set R number to R, no R. Okay, so otherwise we have some kind of a string. Let's create a pointer as well. And we'll set the pointer equal to find char from left, and we'll give it the string, and we'll search for a dot. Let's create static file name. Name. and a file name pointer. Okay, so if we don't find any dot, then we can just copy this into the file name. So we'll do a mem copy. And the destination is going to be the name.name. Source is just the string, and the maximum size is 8. However, if we have a dot, by the way, let's start by zeroing out this thing. So we'll zero name. We need to know its size. So size will be equal to the size of a struct s file path structure. So else. So now we know where the dot is. So we can start by copying into the extension, and that will just be p+1. We'll copy at most 3 bytes. Yeah. Okay, so that's one part of it. Then we can set the p, which points to the dot. If we set this to int it's 0, now we can just do a regular string copy. And the destination will be the name.name. The source in this case will be the modified string, where the dot is replaced by a 0, so we'll only copy the name field, the name part of it, and at maximum 8. So now we should have this structure filled out. Let's set our file name pointer equal to the address of name, and we'll return that pointer. This should work, right? So string to file. Internal file name string to file, and it takes an int 8 star. Okay, that's good. Good, good, good. So now that we know how to do that, so let's see, where were we? We have found the slash, so this now points to the file name. So let's set our p pointer equal to no, we need a file name pointer. So name is equal to our new function, which is string to file, and we'll give it p. So if this returns an error at this point, what does that mean? It's an empty file name. Then we can return, if we don't have a name, we can return an error of our file name. Otherwise we have this name structure, so we can just copy that whole structure into our path. So into our path dot target. We called it target, didn't we? Static path. No, we didn't. Let's call it target. So path dot target, and we want to copy from our name, and we need size as well. So let's create an int16 size. Set size equal to the size of a struct as file name structure. And let's cast this so it works. So this should be an int 8, and we need the address. This should also be an int 8, and this should be, well, it's the correct one. Okay, so now we have copied the target file name into our structure. Now we need to deal with the rest of the path. And we want to do this recursively. If we do p minus minus. So we move this back to the slash. And we set p equal to 0. Which means now we have a 0 byte here instead, which means this string ends right here. And then we want to recursively go through this thing. And we need to do it from the left. And by the way, do we need the slash here, or can we just skip that? Because we know we will always go to the root directory from the start. Yes, let's remove that. So we can remove it by increasing our string. So str++. So now we're left with this. So the first thing we want to check is, are there any more slashes here? If not, we are practically done. So let's do a search again. Set p equal to the find char from left. We give it the string and slash. Probably need to cast these. And if we don't get a match, it means we only have one level. So in that case, we have something like this. And we can just copy that into the first part of our array. So let's see, this is it's an array of pointers. Is that what we want? We know these are directories, and a directory is always at most 8 character in name. And let's say we have the null terminators here. So we have an array of arrays where the first part, let's see, it's the other way around. So we have a couple of these, at most max depth, and each of them are up to 9 bytes. So in the case of this, we can just we can do a string copy, and we copy into our path dot What did we call it? Dir path. So path.dir path, and this is the first of them. So this is where we want to copy to, and we want to copy from a string, which is just str, and we want to copy at most 8 bytes. And that's the only thing we need to do, basically. And at the end, we also need to set the other field. So we need to find the file system assigned to this drive number. And we probably need to do this in the beginning. So when we have dealt with the drive number, we can find the file system, right? So let's see. If we have a file system, we could use that, but we don't want to do, if we would want to override the file system provided if we have one in the path. So drive is equal to fstd drive. Maybe the easiest way is just to do something like this. Our path prime dot fs is equal to the what did we call it? Fs descriptor of the drive number. And if this path is not there, then we try to set the path to the fs provided. And if it's still 0, then we need to return an error. And what kind of error is that? Error drive. Like so. Alright. So now we have filled in the drive number. Did we No, we're at the wrong one. No, it's this one. Did we copy it into this structure? No. So let's check that we have a drive number. If we don't, we can return an error of error drive. Otherwise, we take the path.drive and set it to drive. So now we have the drive, we have the file system, we have the target, we have the first of these paths. So the only thing left is to set the path pointer equal to the address of path prime, and we return this pointer. Okay, so that's for the case where we only have one layer. But if we have several of them, then we need to have some kind of recursive function. So let's say we have a function which is called private let's see, bool maybe, and we'll call this parse path. So we need the string. We need a pointer to that path structure. So path pointer. Right. So now we're going to search from the left. Let's create an int 8p and we set that equal to find char from the left, and this will be the string and the let's also add an index here, by the way. So int 16 index, and what we're going to search for is this /. If we don't find any, which we should, but let's check for that anyway. Well, it's not sure that we should actually, because if we would make this a recursive function, it will by the end of the recursion, it will only have one string without a slash, and that's when we're going to end. So then we will just, let's see. So now we're down to the last level, which means we want to copy. So we want to do a string copy into the path pointer and I always seem to forget what we call it, the directory path at the index. And we'll just copy the string as is. And this will just be directories, so at most this will be 8 characters. And then we can return true. Let's also do some sanity checking. Let's check that we have a string and that we have a path pointer. So if the string is null or the path pointer is null, then we can just return false. If the index is equal to, or is more or equal to the maximum depth. So let's see. The index will go from 0 to 15. And the maximum depth is 16, so we need to take -1. Max depth -1. So now I've reached the maximum depth. That means we will not be copying anything more. No, we should not do -1 because the index is going to be 16 at this point. So if it's more or equal to the max depth, then I guess we just can return true. Because along the way we have probably been able to deal with this. Okay, so that's that. But what are we going to do if we find a slash? So in this case, for example, or it can be even larger. Let's say we have some config error here or something. So we want to keep handling this from the left. So P is equal to the position of this slash. Let's create a copy of this string thing. So we'll have a string prime, so we don't overwrite the original string just yet. But it doesn't really matter if we create another pointer. It will still be pointing to the same string. So what we need is a real copy of this. So let's do int 8 str prime at size 9. I'll start by zeroing it out. 9. And we'll do a string copy. Oh, by the way, this is the whole path, so it can be bigger. Let's say this is 255. So we string copy into I changed my mind. I don't want a copy of this. It doesn't matter if we change the original string a little bit. We will and do it anyway when we recurse. So let's skip this. Right. So in this case, we know where the slash is. Let's change that to a 0. And we'll do a string copy into our p pointer at dir path at index. And we'll copy the string and at most 8 bytes. Okay. And this P is still pointing towards this position. So we can increase this P, and now it's pointing to this part that we haven't parsed yet. We can also increase the index. And now we simply return ourselves. So we return the parse path of our P. And the same P pointer and the new index. Let's say this is index prime, by the way. The index I think I want to have a copy of. So index is equal to this. So we can increase it and we give it here. By the way, let's make room for max depth +1. So we can have that null terminator even if we fill the whole thing. And before we return, so in this case, and in this case, when we return true, we want to input that null terminator. So the easiest way will probably be to dereference p pointer dir path at index and just set it to 0 like this, and then we can return true. And let's copy this and do the same here. Only in this case we need to increase the index first. Alright. Quite a special function now, but I think it's going to work. So how do we use this? If we just have one level, we copy it like so. If we have more than one level, we want to run the function. So parse path, and we will give it the current string. And give it the address of the path structure. And the index, the first index that we want to copy into, is going to be 0, right? Let's also take care of the return value. So we'll have a bool ret we'll set ret equal to this, and if this returns false, then it meant we weren't able to deal with this string. So then we can just return an error of error path. Otherwise we set our p pointer to the path and we return the p pointer. Okay, I think we are done. We might also want to make everything lowercase. And we might want to check that it is containing valid characters. Right. We need something similar to the function we wrote, which is the valid which is its valid file name. Let's see, valid fname. What does it do exactly? Valid fname. Let's just copy this whole thing. It's not very dry, but sometimes it's the best option. And we'll call this valid path name. And this will just take a string in date name and no file type. If name will return error. Else if file type extension, we don't need this. And it should be equal to the length of this string. So string len of name. We can remove this. The rest looks kinda good. But we need to use another valid char as well, because now the slash is valid, right? Sure. Let's say we have a possibility to give extra characters. No. Let's just do a valid char prime function. And this takes from valid path chars instead. And when we do valid p name, we say valid char prime. Sometimes the easiest solution is probably the best one. So valid char will also have a valid char prime. And valid f name, we will have a valid p name, which does not require a type. And we need to copy this constant and call it valid path chars. And at the end we add the slash. Alrighty. Okay, that was a mouthful, all of these different functions. Let's copy this error thingies. We go into our OS, paste those in. And now we're done with this function. But does it work? That's a whole different story, right? So let's see, make path. Don't have any really good way of testing this out though. We could just make a path and print some part of it. Yeah, let's do that. So we'll go to our FS format and we will create a path structure. So we'll set the file path equal to something like, let's take the example we had. So C:, dido, /didos system 16 config driver.sys, something like that. If we don't have a file path, we can print that. But if we do, let's print the thing at index 1. So this would be the file path dir path 1 is equal to, and this is a string, so file path and dir path at index 1. Let's also print target. So file path target is equal to this. File path target. Need to turn it into a char string. Same here. Alright, let's see how many errors we need to fix. It will probably be a couple. So we make clean, jump down a little bit, clear the screen, we run make, and boom. Yes. Max depth undeclared. A dir depth. Okay. Let's call this max depth. I think I used it all over. Useless storage class specifier in empty declaration. In empty declaration. Is that because of the constant? Perhaps. Maybe we can skip this for now. Conflicting types for path. Abstract as path. This should not be there. Assignment to int star from incompatible type, incompatible pointer type. So this is 165. File path is equal to, well, we cannot just set it like this, right? We want to use our function. So make path, and it takes a string like this, and it takes, let's try without the file system first. So instead we will just give a file system 0. What else? Dir path in something not a structure or a union 170. Well, this is probably also because of that constant thing. So let's do another make. Alright, 172. File path targets. Okay. Okay, so this is a file name structure. So let's provide we'll use our helper function, our file to string, and we give this. So this is why you should make helper functions. It drastically makes things easier. Implicit declaration of string copy 326. So this should be copy with an O. Incompatible type for argument 1 of file to string. Struct as file name, expected file name star. Okay, so it wants the pointer, is that it? Probably. Conflicting types for valid p name. Int 8 file name star. Did I mess it up somehow? P name. So valid p name takes an int 8 star. Valid f name takes this. So valid, right. So valid p name should take an int date star. Valid p name defined but not used. Valid p name. Really? Valid p name. Right, and maybe I didn't put it in there. To make path. Let's put it here. So if valid p name of string is false, we can just return an error of error path. What else? Read directory defined but not used. Well, we're not done with that, are we? Read directory. No, we're gonna use that for our open dir, I think. Okay, so now we only have to fix this structure thing of incomplete type struct as file path. Incomplete type. Useless storage class specifier in empty declaration. Is it because I made it private? No. Incomplete struct. Size equals size of struct s file path. Internal struct s. Oh, path. Okay. So the error is if we search for file path, this should just be path. And now I believe it will compile. But will it work though? That is the question. We got nothing. Oh wait, I added it to fs format. I should added it to fs mount. So we'll remove this, put it here. We'll cut all of this out, and we'll find the fs mount instead. And here we'll add this, and remove this part, and we can copy this up here. Alright, let's try this again. No file path. So let's check the error code. Error is 0D. So F is 15, E is 14, C, D, so D is 13. And if we go to our OS, okay, so this line is 43. 43 plus 12 is 55. Error drive, okay. Error drive. What happens if we don't specify a drive, but we do specify a file system? Will it make a difference? No. So let's go to the make path. The index should be drive -1. That didn't help much. So let's see, error drive. How many different places do we return that? We do it here. and we do it here. And if drive is 0, we also do it. So if we have this colon, we do this. If we don't have the colon, and we don't have a file system, we return an error. Otherwise, we set the drive number. So drive is equal to this. It's weird. It's weird that it returns the same error no matter how we use it. Fs mount. Because now we just give it this and we provide a file system. Fs descriptor idx is equal to, and where do we set the idx? It's drive -1. What if we do this? Same thing. Let me just double check that D is really that error. This should be a dot. Oh, our drive is 0C. We were one off. So what is the one be? Let's see. It should be the one after. Error path. Okay. Let's double check, by the way, so we don't do this jumping through hoops again. Alright, that's good. So now we have something to work with at least. Make path. So error path. If it's not a valid p name. Well, we forgot one thing, didn't we? Because we are checking. No, we're not checking the entire string. Because we are increasing this. So I thought I was going to add a colon to that thing, but maybe we should do it anyway, just to be sure. But I don't think it's going to fix this problem, but it might be useful later. Okay, so valid p name can return error, but it can also be this if we don't find a slash. And it can also be this. If the parse path fails. A lot of different alternatives. Maybe we should try a smaller path to begin with. So we go to fs mount. And let's change this to just one directory, one file. And let's print the first of these dir entries. Same thing. And if we just have a file, same thing. So let's start by figuring out which of these that's failing. Okay, it's valid p name that fails. Alright. So what does this function do? It takes in the string, calculates the length, we set return to true, p equal to name, loop as long as we have an n minus minus, p plus plus, and if valid char p is null, return false, break, return ret. So it must be our valid char prime that's failing, I guess. It looks right, I think. Let's do valid char of some char equal to this. Okay, let's try this. Oh. Oh, the dot. The dreadful dot. So let's see, where were we? Make path. So the problem is we need to add our dot to the valid characters. Let's try this again. Okay. This time at least something else did happen. String to file is crashing. We try to move into the memory address inside of EBX A0 inforeg EBX. Why can't we do that? Byte pointer EBX 0. (28E) 28E. That's a bit weird. String to file. Must be here. Yeah, because we have found that dot. And find char. So It's from the haystack. What is the calling function? KFS mount. So it's this, right? File to string. No, str to file. Fs mount calls string to file. String to file. Name is equal to string to file of p. And where does this p come from originally? It's based on the string. Aha! Now I think I know what's wrong. Because we give it a constant string here, and that's read-only. So that's why we get into trouble when we try to edit it somehow. So for now, let's just cheat a little bit, since this is not a part of the actual function. Let's do a string dupe of this. And I think we should be okay. Okay, man 2 3 string dupe inside of string.h. Alright, let's see what happens. File path, system 16. File path target, driver. Okay, let's see, targets. What exactly do we do here? Fs mount. File path target, file to string. Well, we don't get the dot and the sys, but the rest seems to work. What if we were to change this to C colon this, and we do it without the file system? Can it find it? Yes, it can. Alright, so the only thing is we need to fix this dot problem, and that can be either because it's just not printing properly, or it doesn't copy the dot as it should. But I think that is all for now, anyway. So we'll be right back after this. Alright, welcome back you guys. The last couple of days I have been recording 15 hours of video content. So my voice is starting to crack up a little bit. I hope we can finish this before I won't be able to talk. But we'll see. Alright, so before the break we managed to finally get this almost to work. The iteration of the path structure. But we don't get the extension, so we need to find out if we are not correctly saving the extension or if we are just not able to print it correctly. So let's create another printf. And let's say this is the target. Let me just check real quick. Alright, so the target is a struct and not a pointer. So if we take the name we don't need to pass this to a function. And let's also check the extension. And see if we get anything. Okay, so the file name is okay, but the extension is 0. So why is that? Why does it properly copy the name but not the extension? So let's go down to our code and see where we handled the target. So let's see. So it's here. We copy it from the name, which should return a file structure. And I'm pretty sure it used to work, didn't it? So let's do the same here. We can print or let's take the source instead. So we want to print name dot name. Name. And we also want to print name.extension. Oh, wait a second. We do a string copy here. So we will probably, when we run into this 0 byte, we will stop. Well, we are copying a file name structure to a file name structure. So we should be able to just do a regular copy here. All right, let's try this. Almost, right? This looks okay. This is probably just because of how I print it, right? So if we go to fs mount, right. I can't print it like this because it's not null terminated. So we can remove this, which means that this is the thing we're looking for, and it works. It actually works. Nice, 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 nice. Okay, so now we can successfully parse a path string like this. So now we can go on and writing our actual function, which is a part of the public API, which is the open directory function. So I wonder, should we put this inside of the OS API instead of the FS? I think we should. So let's clean up a little bit among my different tabs. And let's open the OS API.c, and let's put this here. And the OS API.h, which I'm not sure if we're gonna need though. Probably not. Let's close this for now. Alright, so first of all we need to define a public structure for this open directory thing. And when we open a directory using this API call, we will get a list of the files inside of there. So that's what we need. So let's see. Don't have any structures here as of now. So let's just put it here perhaps. Alright, so this will be a public struct s file list, or maybe we should just call it a directory. And what kind of information are we interested in? So let's see. So this will either be used as a struct, so there will be one for each entry, or it would be a linked list. But I think an array makes more sense. So each of these maybe we should create two structures actually. So let's say this is the directory. So we want to store the inode. We want to store the name of the directory, perhaps. I think that makes sense. So file name, dir name. We want to know how many files there are. So we need to have some kind of int16, let's say size. No, that's not good. Length maybe. Let's see, what else can we have in here? I think we are okay with this. So for now, let this be packed, and we typedef this thing and call it a directory. Then I want to have another one for the actual file list. So this will be the S file list. So one entry per file. Maybe we should call it file entry. So for each file, we want to know the inode. We want to know the name. We want to know the size. And we want to know the type. This will be packed, and we are going to typedef this as usual. File entry, file entry. Alright, so now that we have our structures, now we can create our functions. So we will have a public function which returns a directory. And this will be opendir. And what are we going to provide here? Well, we need to have a pointer to that inode, so we know which one. We need a file system first of all. and we need to have a pointer to an inode. Do we need to save the file system in the directory structure? I think that makes sense. And maybe even the drive number. So the file system, a pointer to an inode, so that's the inode number of this directory that we want to open. Now I will let's change this. Actually, the only thing we are interested in is an int8 string, because we want to parse that. So the public API should be easy to use. We just want to give the path string, and this function should take care of the rest. Okay, so let's write this function. This would be very complicated if we didn't have all of these utility functions that we created previously. So we will have a, let's see, we should not put this inside of here. I think here is a good place. Which means we need to include fs.h include. Alright, so it's a public function which returns a directory, or a pointer to one rather. Open directory int8 path string. If we don't have a path string, by the way, first we'll set the r number to r no r. And if we don't have a path string, we can return an error of argument error. So the first thing we want to do is turn this path string into a real path structure. So let's create a path. Let's just call this P. So P should be equal to make path, and it will take in the path string and no file system. Because we shouldn't need to provide a file system to this function. And if we don't have a P, we can return the error of r path. Or rather, we can throw the error. So we return the same error as make path returns. But if we have a path structure, we want to iterate through it. So let's see how a path structure looks. First drive, file name, and then the path. So let's first check if the path is, if the first entry is 0, because in that case we can go directly to the target. Which is not very likely though. Since it requires a fully qualified path, at least as of now. So scratch that. Instead, we will start iterating. Or we can check if it's empty, because then we can return an error instead. So we will go into the P and its directory path and its first entry and the first character of that entry. If that is 0, we will return the error of bad path. Sorry about the sound. My cat is going a little bit crazy right now. Okay, so what's the first thing we want to do? We want to open the root directory. That's what we want to do. So let's see, we want to use our, what did we call it? Is it find inode? Let's see, what does it return? Find inode. It returns an inode structure and it takes a pointer to an inode number. So let's say we have an inode and we'll set this equal to find inode, and we will use the file system from P, and the root directory is block number 1. So this should never fail, but who knows if it does. Let me just check if this find inode function has error handling. Find inode. Return 0. Okay, so the only way this can fail... No, there are multiple ways. Let's do this. We'll set the R number equal to R no R, R no R. If we don't have a file system provider, let's return the error of argument error as usual. If dread fails, we will return the error of IO error. And if the memory allocation fails, we'll return the error of no memory error. But what if we have gone through all of the inodes? What happens then? Okay, we return ret. Maybe we should do this. So if ret is 0, it's better to return a proper error and let this be error not found, I guess. So do we have any memory allocations? We have this. But that's only if we set the return value. So that should be okay. Alright, so now we can propagate this error too. So if we don't find an inode, we can just throw. We need to destroy the P though. Like so. Okay, so otherwise we have the inode structure here. And what does that contain? It's this. So what we want to do now is we want to search the root directory for the first thing in our path. So I think we have some find file or something. We have a lot of functions now. I'm sure we have some kind of function like that, but where did we put it? Find file. No, that's not it. But we did at some point search a directory for a file. sure we did. Parse path, valid pname, valid char, read directory. Ah, that's the one, I think. So this takes in file system and a haystack, so that would be our root directory. And the needle is what we are looking for. And this will return an inode number. Okay, perfect. So let's create a pointer, inode pointer. And our inode pointer will be equal to this inode's well, it's going to be equal to 1, right? That's the root directory. So we need a for loop where we set the inode pointer equal to 1. We are going to loop. We need to have a proper counter instead. So we'll set n equal to 0. We're going to loop as long as n is less than. No. We are going to loop until we find the null byte. So let's see. We have the p and then the directory path at index. And if the first character is positive, then we're going to continue looping n++. All right. So maybe we need an temporary variable. So we'll set temp equal to read directory, and we take the file system from the p. Then the pointer. So this is where we are searching. So that's the root directory, which is being pointed to by I pointer. And we need a file name structure. So let's create one of those. File name, name. And we want to zero out this thing. So we do also need this size thing. Okay, so first we zero out that, then we want to copy into it the the directory name. So let's do a regular memory copy. Let's reuse this size variable. And let's take the string length of the P directory path at n. And if we don't have a size, what do? Well, we are done then. So break. But this shouldn't happen. So now we can do a regular memory copy, and the destination will be our file name structure. So name, or rather name.name, because there is no extension. We wish to copy from P directory path at n and we want to copy at most size bytes. So now we can use this to find our L2 or to read our directory, and the TMP should be equal to a number, a inode number. So if it's not, then the path is not valid, and we should return an error. So let's see, what do we need to clean up? I guess the only thing is the P. So destroy P and return the error of err path. However, if we do have a directory like this, we want to set our I pointer to that. So this will make it an iterative process where we open one directory at a time until we have parsed the entire directory path. And when this loop is done, our I pointer should be equal to the last directory in our path, which means now we want to do a similar search. So let's copy some of this stuff. Now we can use the target. So now we want to search our target file name or directory for in that position. So we will do a read directory of pfs. We give the I pointer, and this time we give the p target. And let's see how it's defined. Like a regular file name. So we need to do this. I guess. Yes. Okay, so at this point we either know if we have found that file inside of the directory or not. So if not, we can destroy our P, and this time we can return the error of not found, because the directory is there, but the file is not found inside of it. Otherwise, we have located the actual file, and it's pointed, the actual directory, and it's being pointed to by iPointer. Do we actually need to use this find inode here? Because we are not using it in the loop, we are only using the number 1 inode number. So let's remove this for now and do it down here instead when we have actually located the directory. So our inode will be equal to find inode, and we have the pfs, and this will be the iPointer. So if we have found the actual file but we're not able to open this inode, then it's some weird error, and we can destroy the P, and we can return the error of our inode, because it's not a file error at this point, it's an inode error. Otherwise, this inode will contain this thing. So let's check that it's actually a directory. So if the inode valid type is not equal to type directory, we can destroy P, we can destroy the inode pointer, and we can return the error of bad directory. Okay, so now we have the actual directory. Are we ready to create the directory let's see, the directory type? We know the drive number, the fs, the inode, the directory name. Well, this we can just copy. Maybe we can do this. The length we don't know, because we don't know how many files there is inside of here. But let's set up the rest. So let's just copy this. No. Okay, so let's see, we need to first allocate this thing. So a directory, let's just call it dir. Size should be equal to the size of a struct s directory. The directory should be equal to alloc size. And if that would fail, we need to destroy the P, destroy the inode, and throw. So we need to make sure that our own allocation function returns, well, it will be a memory error, right? Right, otherwise we will zero out this thing. And now we can start filling in the blanks. So our directory drive number will be our pfsdd drive. Our directory, it's messed up. Okay. Okay, there we go. So our directory file system will be equal to pfs. Our directory inode number will be equal to our inode pointer. Will it though? Well, we need to set our inode pointer equal to the TMP in this case. Right. And then we have the directory name. So let's just do a regular copy. So into the directory, no, yes, directory name. We should copy the string from so it will be from the p target, right? And the maximum size will be 8. So now I have everything but the length, or rather the number of files inside of this directory. So let's see how we can figure that out in the best possible way. We need to iterate through all the pointers inside of the inode. I guess we need some utility function for that. So let's see. Maybe we can call it something like make file list or something. So we are going to have a file list fl. Well, it's called file entry. So let's say file entry file list, because this will return multiple entries, possibly. So our file list will be equal to make file list, and we will need to give it a file system. So the directory file system, what else does it need? It needs the inode of the actual directory. Or at least the inode structure. Maybe that's better. And we just want to iterate through every file and grab some information. So I guess this is all we need. So we'll have an internal file entry make file list. It's going to take a file system, fs, and an inode. Let's call this, well, it's not the root directory, but it's at least well, it's a directory. So file entry file list. Probably gonna need an I pointer, and we are going to need int16n and probably a size and an inode structure. So first we're going to go through all the direct pointers. Or first we want to check that we actually have a file system. And a directory. Okay, so a for loop where we set n is equal to 0. We loop as long as n is less than pointers per inode, n++. Set the I pointer equal to our directory direct at the index. And if this is 0, we'll just continue. If it's not 0, we have found a file. So in that case, we want to set our inode equal to find inode. We take our file system and our I pointer. And if this is somehow not valid, we can just continue. Let's also create file entry let's call this the file list object. Let's not make this a pointer or array better. Let's say we have a constant which is max files per directory. And let's go to fs.h. And how much is this? Well, we have room for 8 pointers. So pointers per inode plus pointers per block. So that's the maximum. Let's also count how many files we have discovered. So files plus plus. So we want to put this file or the info about it inside of the file entry at that index. So maybe just to make things a little bit easier, I will do entry. And entry will be equal to the address of the array at the index of n. Or not n, files minus 1 actually. Because if we have found one file, we're going to put this at position 0 in our array. So let's see what information we are going to copy. So these things we need. So let's set entry inode equal to, this would be our I pointer. And then we have the file name. And maybe we shouldn't keep that as a pointer, because we don't know what's going to be freed between here and our return. So let's make this a regular structure instead, which means we need to copy into our entry file name and where do we get the file name? Well, it's inside of the inode, so inode like this, inode name. Let's set the size equal to the size of a struct as file name, and that's our maximum bound. Okay, so that's the file name. Then we have the size. So entry size is equal to the inode size. Easy one. And the entry file type is equal to the inode valid type. Okay, so that's all we need for this entry. And this we will do for each and every pointer in this inode. But then we might have a couple of indirect pointers as well. So let's see. So if the directory indirect is equal to 0, then we are done. Maybe we can do the other way around. So if it's not equal to 0, in that case we need to do some more stuff. We need to read in that block actually. So let's say we have an fs block, which we will start by zeroing out. So this will be the block size. Maybe we can do this. I pointer is equal to directory indirect. And we'll check this I pointer because we want to do other stuff with this I pointer as well. So this I pointer is pointing to a block in this case, which makes I pointer a little bit bad, but with name, but I don't care. So now we are going to do an disk read, and we're going to read from the fsdd. I'm going to read into block data, and we're going to read the block number I pointer. Let's also catch the return value, bool ret. So ret is equal to this. If this failed, then I guess we are done as well. So let's check if it doesn't fail. So now we have a block full of pointers and we want to iterate through them. So we'll do a for loop where we set n equal to 0 as long as n is less than pointers per block n plus plus. So our I pointer will be equal to our block dot pointers at n. And if it's 0, then we don't have anything else to do, so we'll break. Otherwise, we basically want to do all of this once again. And this should be contained inside this for loop. And we probably need to change a couple of things, so we need to look through that. Okay, so we search for the I node based on the I pointer which we got from the block. If this fails, we'll just continue. Sorry. If it doesn't fail, we can increase our number of files. And we can keep filling out this array thing. We can take the pointer, the file name, the size, and the file type. So this will be the same thing. Okay, so now we have a big structure. Wait a minute, one more thing. This I node, we need to remove that when we are done, so we don't leak any memory. So we destroy the I node. Right. Otherwise, when we are done with all of this, what we can do is, let's set our entry to the array at the number of files. So this time not files minus 1. So this is the last entry. Or never mind. Okay, so we know, by the way, almost forgot, we need to destroy the inode here as well. Okay, so now we have on the stack this array with all the different things. Now we want to allocate something we can return. So the size is going to be equal to the size of a struct s file entry. What's that the correct name? File entry, yes. And we need to multiply it by our number of files. So now we can set our file list and allocate for it. So file entry alloc size. If this fails, do we need to clean up anything on the heap? Inode we have taken care of. No, I don't think it's anything more. So in this case, we can simply just return a memory error. Otherwise, we want to copy our array into this. But let's first zero out the thing. And then we copy into the file list from our array size bytes. And then we can return the file list. Okay, so now we have the possibility to create a file list like this. So in our open directory function, we have created this file list. Or if it didn't work, we need to clean up a little bit the P. Okay, that was not my intention. We need to destroy our P, we need to destroy our inode and throw the error. If we do have a file list though, I guess we are done and can return our directory. Only thing we need to do is we want to set our directory. Well, now we know the length too. But how do we communicate that? The file list will not contain that. We need a tuple. So let's go into the os.h and we will define another structure, which is the public struct s dir tuple, or maybe just tuple, which will simply contain an int16 num files, and it will contain a pointer to the file entry list. So file entry file list. And a tuple, by the way, is just when we return 2 values and not 1. So in this, so by the way, we need to change the signature. Instead of file entry, this make file list should return a tuple. So we need a tuple, tup, set size equal to the size of struct as tuple. Tuple will be equal to size. We are going to zero out this thing. Tup size. We are going to set the tuple num files to files, and the tuple file list to the file list. And now we can safely return the tuple instead. Let's also update our signature. I don't even think we have created that yet. So let's do that. This should end up inside of the OS API. Which we don't have open. Okay. So now we return a tuple instead. We need to take this into account here. So we don't need the file list, but we do need a tuple, tup. So now we can set our directory Well, we need to put the actual file list here. So our tuple will be equal to this. And we can set our directory length to the tuple num files. We can set our directory file list equal to the tuple file list. Now we can destroy a couple of things. Let's start with the tuple and the p and the inode. And we can return our directory. Yay! And this function is done. Open directory. Alright, so let's see if we can compile this thing. Maybe it's a bad place to put these inside of here. Let's put it among the other ones instead. So what about the signature? Because it returns a directory. And I guess it's not possible to do something like no, it seems unlikely, right? Maybe we need to include the fs. Unknown type directory. File included from OSAPI.c. And what if we move this here? File entry. Undeclared. Maybe I put them in the wrong order. Here is the file entry. This uses the file entry, and so does this. $156. File entry has no member named file name 247. So what did I call it? Name. Maybe I should rename this function copy without the O. Directory name. So the directory name, what kind of structure is that inside of the directory? It's a file name. And the target inside of P, which is an path structure. Targets. Into the dir name we copy. Okay. Unknown type directory. Maybe we should just do, if we remove this here, what will happen if we just include it at the top? Will everything break? Yes. And if we do it this way around, which part is not working? So we go from osapi.h to the disk.h and the disk.c. And I guess we can't just include the fs.h here, or can we do that? Disk.c. Maybe we can do this. Maybe I should have made a better structure. So it's more like a tree where we include different things. Maybe we can cheat a little bit. Since it's only one data type at one point. So what if we just said that this would be void? In our .c file, this too will be void. We'll return the directory we just cast it to void. At least this can be some temporary solution. We'll figure out a better way later on. Okay, we don't have the void declaration. Unknown type tuple OS API. How can we organize this in a good way? Until we figure that out, I will cheat a little bit again. Just copy this thing. And that doesn't help since we still have it in the H. So let's put it here. But the library is defined, I think, even when we compile the fs.c. But let's try it. And we didn't remove it from the FS, right? No. However, if we paste this inside of here, it will probably just complain about the file list as well. But let's try it out. Yes. Let's see, if we go to fs.h, we include the OS API.h. Do we really need to do that? Well, if we were to remove that and instead we just include, we include it the other way around. Uh, 17. And I guess we need to do the same thing in the disk.h then. So let's just remove this. And let's do it here as well then. No, it's raining errors. So I don't want to spend too much time on this. Let's just do some hackish solution to this. We can move this make file list into fs.c .h, which actually makes quite a lot of sense, I guess. And let's move the code then as well. So this function and this, well, at least this, I think. So from OS API to this file. So where are we at now? disk.h, OS API. Should we not include this? I don't remember how I did it before. Disk.c, disk.h, omnistd.h. Everything is just in flames now. I think I need to go to a backup and see how the include structure worked. So BKB, and this is the FS now. GDOS. Alright, so the OS API.h, let's start there. Looks right. And the disk.h should include those two. And the fs.h. OS API and disk. And the Omni STD. STD IO and OS API. Okay, I think it should be okay now. Disk.h, OSAPI.h, unknown type name disk. How can disk not know about disk? So this includes disk.h, then we go to disk.h and we do this and this. This contains these. What exactly does this error say? It's when we're compiling the disk. We have disk.c, it includes disk.h, which includes the OS API. So the OS API.h does not know about the disk. Or the fs.h. So how do we get to the fs.h from disk? Maybe I need to resave these. Okay, that was a problem. Whew. Multiple definition of make file lists. So I probably need to resave the C files as well then. It's a lot of code in this project, right? Okay, that's more like it, but we don't know where make path is. Make path. And this is where, when we are linking, make path. Well, it's here, but it's private. So let's make that internal instead. We can close disk and omni OS2, I guess. So let's see, we need to update the signature. Make path should be internal. And now, ladies and gentlemen, I believe this will compile. Yes, it does. Okay, so how do we test this? If we go into the fs mount, we still have this path here. Um, we are going to provide just a string. So let's change the file path into an int 8. And we don't need make path here. This should be enough. Well, we need to choose a path which does exist, right? And what is the signature of this open directory? So it will return a file. No, it will return a directory structure. So directory dir. Right. So our directory will be equal to the directory casted open directory, and it takes in the file path. If we have a directory, and we want to print some stuff. Did we copy the length though? Num files, file lists, make file lists. Yes, we did. And plus plus. And for each file, I'm going to print one line each. And we'll use our file to string, and we will give it the directory file list of n dot name. N undeclared. Struct as file name, expected file name star, okay. Okay, it compiled. Fingers crossed. No. Maybe it doesn't work so well when we have just the root directory. And I can't remember how what we put in here. Let's see if we can just do a hex dump -c of our drive. Yes, we should have a DDoS folder. Let's use it instead. Okay, that turned into an endless loop. Is that because we don't have anything more here? If we had foo, what would happen? Same thing. Doesn't give a whole lot of information. So the redirectory hangs. Am I calling the wrong redirectory function? What if you were to call this 1? Okay. And then read directory 1. Undefined reference to read directory 1. Okay, let's make this internal. So memory. What did it say? Undefined reference to memory compare. Where did I put memory compare? What am I doing? compare. That's weird. Well, is this the only way we have used that compare function? Can't be, right? Well, maybe it is. Maybe we never made that function. Well, shouldn't be too hard, right? Let's copy this thing. So memory compare. We have, well, let's call it destination and source, doesn't really matter. And the size and a bool if it should be handled as a string. So we go through the entire thing, and if dp is not equal to sp, then ret will be false, and we break. Otherwise, we just return that return value. Conflicting types. Int 8, int 8, int 16, bool. This should be a bool. Alright, hopefully it will compile now. Yes. Let's see what we get. That is probably just when I try to print this stuff. So fs mount. Let's just remove this. No? Invalid pointer. Well, let's do this. If we have a tuple, we destroy the tuple. If we have a p, we destroy the p. And if we have an inode, we destroy the inode. Okay, that's not it. Then it needs to be the other function, right? This one. So we search for destroy. If we have an inode, we destroy the inode. If we have an inode, we destroy the inode. And now we're something else, somewhere else. Hey, little puppies. My cat is going a bit crazy again. Let me just real quick do this and start, continue, backtrace. So it's from the open directory. Okay, let's go through all of them here as well then. So if we have a P, destroy that. If we have a P, if we have a P, if we have a P, we destroy the P. If we have an inode, we destroy the inode. And same here. Alright, now it shouldn't be able to fail like that. But it does it anyway. Create breakpoint, F, start, continue, backtrace. Okay, maybe we overflow something and it's not a double free error, it's some heap data that we are accidentally overwriting. That's not good. Well, I think we need to take a short break before we troubleshoot this. I'll see you in a bit. Alright, so welcome back, you guys. Now I think I know what the problem is. So the GDB output said that the open directory function called free in a bad way. And if we look at this, we have a path pointer, P, and we use the make path to generate this. And the make path is, by the end of the function, returning a pointer pointing to a path variable, which in turn is a static structure. So it's not allocated by malloc. That's why this is happening. So we should absolutely not free this P. So let's just find all places where we try to do just that. And we get a little bit cleaner code by the same time. This inode though, let's double check the find inode function. Find inode. What does this return? This return ret. And ret is a pointer to an inode. And how do we allocate ret? Using malloc. So this one is okay. This we will remove. And this we will remove. And this as well. What about the tube? It's returned by the make file list. And I think it's inside of this file as well. Make file list. Alright, so this function returns the variable tube. Tube being a pointer to tuple. And tube is allocated with malloc. Alright, so now I think we should be okay. So we make clean, jump down a little bit, clear the screen, run make, and boom. Compass, will it work? We didn't get a crash, but we didn't get much of the output either. So let's go into our FS mount and look what we have. So we create a file path. And if we have a directory, we print that stuff. But this directory does not exist. So that's probably why. By the way, let's keep it as is. And let's print an error in this case. this will be the char of error number. That way we can see if it is a file not found error. So the error is 0D. And a D is, let's see, A, B, C, D, E, F, 13. So let's be a little bit clever this time and copy this stuff. And just open an empty file and paste it here. So line 13, error drive. Wait a minute, it's probably 0 indexed, so error not found. Okay, that's good. And we can verify this by checking what the error not found. Error not found. I should create a backwards function which provides the string representations, but that's for a later episode. I went the wrong way. Error not found is B. A, B, C, D. So we need to go 2 steps ahead. Error path. Okay, that makes sense. Okay, so let's try it with some directory that we know does exist, like this, C:\DOS. We still get an error. What if we were to just take the root directory? What happens then? Same thing. I think it's maybe time to create some show functions. So one thing would be interesting to be able to print a path structure. So let's say we have something like private void. Should we call this show path? And it will take a path, file path. And the file path looks like this. Let's copy this thing. So let's see. Let's say we have an int 8p. And if we don't have an fs, we will return. Otherwise, we'll start by printing some info about that. So we can print, let's see, let's do this. So file system, and this will be a 0x%.08x. Maybe we can do this. Then we have the drive. And let's express this as following. So .o2hhx and then the target, and this should be string. Alright, so first we have the integer file system, we have the char, well, it's going to be the file path fs and the file path drive. And the char version of file path target. So that's the first thing we're gonna do, and this should not be fs, this should be file path. And now we want to iterate through the directory path. So let's do something like 4p is equal to should be equal to the directory path 0. And we'll iterate as long as we have a p. At each iteration, let's see, this is an array. Maybe we can do this. So we have an int16 index, or n. We'll set n equal to 0. each iteration p should be equal to directory path ++n. And we want to print 2 spaces maybe the index as an integer and then the string. So this will be a regular integer and this will be p. And then we return. So inside of our fs.h we will have a private void show path, and it's going to take a path. And how are we going to use this thing? So let's see, if we go into this right here, we open the directory, we make the path, we iterate through it. Maybe we should make this internal instead, so we can use it inside of the OSAPI.c. So internal. So it's, when we have this path, we'll do a show path of p. Conflicting types, private void, internal void. Internal. Oh, I changed the wrong thing, didn't I? It should be this one, internal. So which did I change? Should have one more conflicting, right? Internal. Make file list, make path, make file list, make path. Well, let's try. Conflicting types for show path. Internal void show path. Const. Let us also update the other error. This should be n, nothing else. 755. The target is a file name type. So we need to do file to string. And we give it the address. Dear 757. Okay, this should be the file path, dir path. The same here. Okay, now it compiles at least. We don't even reach that point. So when we call open directory, we try to make a path, but it fails. And what is the argument we provide? So fs mount. So let's see. What we do is we open the directory of file path being our root directory, okay? What if we were to use something like this? At least it should be able to create one of these structures, right? Yes. Alright, so the drive is the c:drive. The target is foo. And the directory dedos. Okay, so that looks good. What happens if we just choose this directory? So, okay, this is interesting. So both the target and the first thing becomes the same in that case. because the target we read from the rightmost thing. And we copy this from string to file. P. And then we change the next slash to 0. And we increase the string from the left, removing one additional slash. So if we just have one level, what does that mean? Let's say we have C colon D rows. The first will select this part. So P is pointing here, and we minus it and turn this into a 0. And we don't have a drive letter at this point. Then we increase the string, moving it here. And what if we have an additional level? So this will be removed first. Then we take care of this. We change this into a 0. And we move one step here. Okay, so in this case it works. But if it's only one level, we run into trouble. So we get the target. So P points here. We minus it, turn it into a 0. So let's do, before we increase the string, if the string is pointing to a 0, then we want to jump past all this stuff. Well, we can even early return actually. Maybe we can move this to the top. So So in this case we only need to do the return. So we return the p pointer. Otherwise we do this str++ and the rest. I think this makes sense. So fs mount. Let's first check if we broke the other thing. So here we should have diedos foo. That's weird. This worked before, right? How can that change? We did break it like this. Make path. Let's see. P pointer is equal to the address of path. Oh, this should be not. Okay. Alright, so this still works. So we have the path diedos foo. So what happens if we change the path? So fs mount and we change it to just this. Hopefully this should work now. No. So let's draw this up again. We have something like this. So first we set p equal to the slash from the right. So p points here. Then we increase p, and we copy this thing to the target part of our structure. Then we minus p by 1, and we change this to a 0. And we don't have this any longer. Because if we have the drive, we increase the string by 2. So the string is currently pointing here. And if the current character is 0, we should return the p pointer. So what happens inside of this function? We create the path. Okay, we should not do this check. I think we shouldn't, right? Because we should probably check the target instead. But what happens here if we don't have a directory path? So this starts at the root directory. Maybe we can do something like, if we have a p directory path 0, in that case we do this for loop. Otherwise we just continue with the target. Alright, let's try that. So let's try it with this again to verify that we didn't break anything. Invalid type argument. Right, this is a file name, 144. So we need to check the p target dot name. Okay, this still works. Let's see if this works now. There we go. We do, however, get a file not found error. Let's just verify that we do have that thing. So let's hex dump our drive. Yes, we have a directory called diados. But do our root directory point to this one? How can we check that? So let's see, where is our root directory? It's the first inode, which should mean this. And everything seems to be 0 all along. Because we haven't really created anything that changes this. Let's do an fs show of this thing. So fs show of file system false. Um, 23 inodes. Why doesn't it show our inodes? I'm pretty sure it used to do that with our fs format. And this runs the same thing. Did we break that somehow? We should make a function for parsing a path structure and finding the pointer to the inode number for the target of the path. Same as we do here, but we need to be able to call this from, let's say, if we create a make directory function, we need to modify the directory where where we will put the directory. So let's copy this thing. We can put it inside of here. Let's say we have a private function. No, let's make this internal. An internal function, and it's going to return a pointer to an inode. Let's call this path to inode. So it's going to take a path structure. So path name. Right, so we need a pointer, I pointer. What else do we need? We need a P, which is the path. Okay, so let's call this P instead. And we need a size. And an N. And a TMP. Right, something like this. Let's jump this out one step. Not this. And let's also set the R number to R no R. Okay, so this is a good function that we will have much use of. So internal pointer, and this was path to inode, and it just takes a path. Name we also need. So we need to have a file name, like so. So inside our OS API, we should be able to comment this out. I don't want to delete it just yet. So I pointer should be equal to path to inode And the path in question is the p variable. And this should not return 0. So if it does return 0, well, unless we are trying to open the root directory itself. So if it returns 0 and we have an R number, in that case we can just throw that error. Okay, so this should work equally well as it did before. 923, 923, R, no, R. Still finds a target. It's good. What's this though? Did we get that before? Error 9. So 9 with 0 indexing should be 10. Error inode. So let's go to fs mount. So the open directory is returning this error. And this should be a valid inode. Let's double check that this is really the error. Error inode. Error inode. Right, so error inode is 9, and this is what's returned. I wonder if this was the same error as we got before we made those latest changes. 0b. So we did maybe break something. Okay, so we have this path structure, and we try to make this into an inode. And it's probably this that fails. So let's double check our new function. If we have a p directory path 0, which we don't in this case because our directory is the target directly. So in our case, we're going to run this first thing. So the I pointer will be 1, which is the root directory. And in here, we try to find the target. And if we don't, we return an error not found, which we should throw here, but instead we get an inode error. That's a little bit weird. Because we're reading the target inside of the root directory. And this should return 0 in this case. So this error should be propagated. Let's try to print what this thing returns. Oh, wait a second. We are checking if we have a P here. We should check for I pointer. That's right. All right. So now we should at least get the error we got before, which we do, 0b. And this is a not found error, which makes sense since our reference is not there. Our root directory is not pointing towards this thing. All right. So let's see. We need to create a make directory function, which should be a part of the public API. So it should be public, let's see, we can let it return the inode. So public pointer, does this exist here? No, that's a part of the FS. Maybe we could move that. So if we go into fs.h and we just copy this pointer type and we put it inside of the OS API, like so. And now we should be able to return a pointer, and this will be the make directory, and it's going to take a string. So we'll put this inside of our OS API, and this will be a public pointer make directory, and it's going to take an int8 path string. And we're going to have a path p. P is going to be equal to make path. We give it the path string and no file system. This returns false. Let's also set the R number so we can use that. In this case we can return the error of, well, we can just throw. Let's also have a pointer index. So let's see. If we don't have a P, we can throw. If we do have one, so now we have a path structure. Now we want to search that structure for everything but the rightmost thing in our path. Alright, so how do we do that in an easy enough kind of way? We can declare a buffer 256 in size, and we can declare an int8 pointer. I want to call this P, so let's call this PP for path pointer. So let's zero out this buffer. And let's do a string copy of our, let's see, the target is going to be the buffer. The source is the path string, and the size doesn't really matter. 255. So now we can set the P equal to, and we use our find char right. We give this the buffer. The address to the buffer rather. And the character is a slash. And if we don't find any slashes, I think we can return an error of R not, let's say error path. Otherwise we are pointing to the slash which is to the left of our target. So let's also create something for that. Target 256. And we'll zero that too. So we can set P equal to 0. then we increase it. So now we can do 2 string copies. We can string, or 1 is enough actually. We string copy into our target, our P, and similarly the size doesn't really matter here. So now our target contains, well, the target, and to get the containing directory, we can set P equal to buff. Since we replaced the slash with a 0, this will be the whole path to our containing directory, our parent directory. Which means now we can set our index to, what do we call the new function? Path to inode. Let's see. We need to make a new path. So let's create a p pointer 2. Our p pointer 2 should be equal to make path of our new string, which is p, and no file system. And if this is not true, we can throw. Otherwise we have a new path. Why do we do this first step though? Actually, we don't need to do that. Maybe we need to do it later though. But let's not focus on that. So path to inode, we need to provide a path, and we have a pp2. And this is the containing folders index. So if this is 0 and we have an R number, then we can return error path. Otherwise we have the index of the containing folder. So now we need to do this step. Which contains the path of the original path string. So this points to the directory that we wish to create. No, let's scratch that. The only interesting thing is that we have the containing directory. So we can call this just pp. And we can remove this pp2. So we have the index of the containing directory. Let's create another index though. So now we want to create an inode. And we do have a function for that, several actually. So create, it takes a file system, a file name, and a type. So let's do just that. We need a file name structure. So let's zero this out. Name, and we need a size. Which is equal to the size of struct s file name. We zero out this thing with the size. And then we can set the size equal to the string length of our target. And then we do a memory copy. Copying from our target. We copy to our, let's see, to the address of name.name. That's what. We want to copy from the target, or its address rather, and we want to copy at maximum 8 bytes. So now we should be able to create the inode in question. So we use our fs what's this called? inode create the text of file system, and the file system will be the ppfs. It takes a file name, which is our name, and it takes a type, and this should be a directory, right? And what is the return value? It's a pointer. So let's set our idx2 equal to this. If this fails, we can return an inode error. Otherwise, we have the return value, but we also want to fix what we forgot before. We need to add this this newly created directory to its parent directory. In order to do that, we are going to need an inode. And the inode should be equal to find inode. File system is ppfs, and the pointer that we want to find is the idx, so the parent directory. If this fails, well, then it's a inode error as well. Okay, so how do we add this to the inode? It should be one of the direct pointers or one of the indirect. So we need to iterate through them. Let's create an n, and we'll do a for loop where we set n equal to 0 as long as n is less than pointers per inode, n plus plus. And we will search until we find a 0. So if inode direct at the index n, if this is 0, then we can break. Otherwise, we continue iterating. So after the loop is done, we can check if it's 0. So if inode if inode direct of n is 0, in that case we want to use that. So we'll set the inode direct of n equal to our new directory's number, idx2. If it's not equal to 0, that means that we have iterated through all the direct pointers, not finding any of them. So we need to keep doing this. by the way, now that we have changed this inode, we need to save the inode as well. We have a function for that, fs save inode. What does it take? Filesystem inode pointer. Okay, easy. So ppfs, and the inode is ino. The pointer, let's see, that is this index. And what does it return? It returns the written pointer. By the way, if we return an error in not this case, but in this case, then we need to clean up that inode we allocated. So in unalloc ppfs, and the pointer is idx2. Then we can return. And here we need to save, we want to save the inode, and if this returns 0, we want to do the same thing. We want to in unalloc ppfs idx2, and then we can throw. Okay, so this is that, but can we return after this? No, we have saved the inode, we have updated all of that stuff. Yeah, now we can return. Do we need to unallocate anything? Yes, the inode. So unalloc, and then we destroy the inode. And we throw, but if it works, we can still destroy the inode, but we can return idx2. However, if we have searched through all the direct pointers, didn't find anything, then we need to take a look at the indirect. So let's first see if we have an indirect pointer. So if we don't have an indirect pointer, then we want to create one. So we need a pointer to a block. Let's say block number. So if we don't have an indirect, we want to allocate a new block, and that's, we coded that so long ago I can't even remember, but I'm pretty sure we have some function for it. somewhere. Perhaps it is in the FS after all. Okay. We have a bitmap alloc. It takes a file system and a bitmap, and it allocates, well, it allocates it at least in the bitmap. Let's see how this looks. So we're at 920 bitmap alloc. What does it do? It just allocates it in the bitmap and returns that. Alright, 920. We can close this and this. Okay, so the block number should be equal to bitmap alloc. It takes a file system, which is a ppfs, and a bitmap, which is the ppfs dd. No, it's inside of the file system. So fs bitmap. And then we get a block number. So we should put this block number inside of the inode. So inode indirect should be equal to this block number. And then we want to save. So we can copy this part. So we save the inode at the index. If it fails, we unalloc. We should also unalloc the bitmap in this case. So bitmap free the ppfs, the ppfs bitmap, and the block number. Okay, but it's not enough just to point this thing. We also need to allocate that inode. So basically we need to do this. So we copy this once again, but we need to change a few things. we need to create a fs block. So fs block bl. Okay, we can remove this. We need to do this differently. So we zero out the block BL and the block size. Then we go to BL dot inodes at position 0. And we set this to the block number. No, we set this to IDX2, our new directory. And that is all the reference we need. So now we just need to write this to disk as well. So we need to do a disk write. The destination, that is block. I'm not sure how we're going to cast this. Let's just do this. By the way, we usually do this block data. So we write the block. We write the FSDD. And the address is the block. And the block number is this. And if this returns an error, we need to clean up a lot of different things. So we need to unallocate this block. So we need to set the inodes indirect to 0. And then we need to do all of this. All right. However, if the save is successful, let's see, this should be moved here. If it's successful, then we are actually done with this directory. So we can just return the inode after cleaning up a little bit. So we're not going to unallocate the inode or the bit in the bitmap. We need, however, to destroy the inode. And then we can just return IDX2. Oh, this function was a mouthful. Let's see. Conflicting types. Public pointer make directory. Public pointer make directory. Oh, I forgot the star, didn't I? Int 8 star. Passing argument 1 of 0, incompatible pointer type 235. 235. Okay, so we need to cast this to something like this. Let's do it here. This should not be necessary. Find char. String copy. What else? Name, find inode, save inode, hit map a look, 0. I think this is okay. Passing argument 1 of find char from incompatible pointer type 239. 239. Okay, so we should cast this like so, and this should be a regular int 8 without the star. We still have conflicting types. Oh, it's complaining because we named the function the same as what the standard C library has. But that error will disappear when we remove the standard C library, but we need it while debugging, so I will rename this function temporarily. Public pointer make directory 1. Public pointer make directory 1. Did I forget to save? Yeah, that was it. Passing blah 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 257. So this should be cast to an int 8. Incompatible types. BL inode 0 is equal to IDX. Have struct inode. Inodes per block. But this shouldn't be an inode in that sense. This should be a pointer per block. So so where did we use that inodes per block thing? Here. So block inode 0, this should be block pointers 0. And now it almost compiles. fs undeclared, that is true. This should be ppfs. And now I think it will compile. Yes, it does. A lot of warnings, but at least it compiles. So how do we test this? Let's try to create a directory. So let's go. Let's reformat the disk first, because we have some errors with it. So we go into the utils and disk util, and we do format c:. Yes, formatting failed. That's weird. I have never seen that error message before. fs format. Let's let's do something like this. If we go into the drives, let's save this as a backup, and then we do ddif is equal to dev 0, of is equal to disk.1, block size is 512, and the count 65,535. So we zero out the entire disk. Which takes a little while. There we go. And now we try to format it. Formatting failed. Why? Illegal seek. Okay, so it tries to mount the disk. And that's why. Okay. We need to go to the, let's see, where does it mount the stuff? I think that is inside of our disk.c and our initialization function dinit. Right, it tries to mount the first drive. Let's comment that out for now. And this too. And we try this again. No, not with strace. Okay, now it works. Okay, so we hex dump drives. Okay, now the disk is clean except for the root directory. So now we want to try to create a directory. So let's go to fsmount. And we go down a little bit. Let's see if we can use idx. So we create the file path. Well, we don't really need to. I think we can comment out all of this. Instead, we just do something like idx is equal to make directory 1, and we give it the string, let's say C:" zeros. And then we print the result. So idx is equal to this, idx, error is equal to this, so 0x%.o2hhx. And this is a char r number. All right, let's try it out. Segmentation fault. Well, maybe it's the same problem as before. Let's do a string dupe here as well then. But this will be all for today. If you like this episode, please like and subscribe, and we will continue this project in a later episode. Thanks for watching. Thanks for today.